Hello everyone. Now we will discuss the question number 9. In the figure, the inner shaded region A represents the sphere of radius RA is 1, within which the electrostatic charge density varies with radial distance r from the center as RA is equal to Kr, where K is positive. In the spherical shell B, outer radius RB, the electrostatic charge density varies rho B is equal to 2K by R. Assume that dimensions are taken care of. All physical quantities are in a SI system. Which of the following statements are correct? Now you can see there are two charged bodies are there. One is sphere, charged sphere. Other one is outer shell. Now we are going to do this. See, for shell, the net charge on shell, net charge on sphere rate, sphere of radius RA is equal to 1 meter. Now we are writing, you take the any a small elemental region there. If you take any small elemental region up to that, let us consider R and the thickness is dr, charges dq. I am calculating dq on A body. I am calculating dqa is equal to, we can write rho into 4 pi r square, the rho A value into 4 pi r square into dr. Limits we can write 0 to Ra. The charge on A can be written as rho A value is K into R, 4 pi r square into dr, 0 to 1. If you write this 4 pi K r square and r cube, so we can write r to the power of 4, we will write 1 by 4. So we can get the pi K is the net charge on the conducting sphere. Now we will see that the charge on shell, outer shell. Sorry, inner one is not conductor, it is a non-conducting sphere, okay. And outer shell, if we see that the charge on outer sphere is how much? The outer sphere, you can see that the sphere is shell is located from RA is equal to 1 meter to RB, okay. RB value you don't know, you have to for different values they have given, you have to see here. Now what is the charge on this one? Let us consider charge on this one is QB. Same thing, one shell you will take here. So we can write QB is equal to whatever density is given, rho B value is 2K by R. So we can write 2K by R into 4 pi R square into dr. Limits we can write it as from 1 to R. Now you substitute there 8 pi K, R one time get cancelled. We can write R square into dr, integral R into dr, 1 to R. So we can get the value is r square by 2. So 4 pi K r square minus 1, r square minus 1. This is the charge on the outer shell. Now net charge on system is equal to, why I am calculating net charge on the system? They are calculating on outer surface of the system only, okay. That's why I am taking this. Net charge Q is equal to, we can write pi K plus 4 pi K r square minus 1, RB square minus 1. This is RB, it is RB square minus 1. Now in this question they have given different values. If RB value is root over 3 by 2, the electric field is 0 everywhere and outside. So now you calculate at RB is equal to root over 3 by 2. At RB is equal to root 3 by 2. First, to get the electric field is 0, charge should be 0, okay. Now we will see whether charge is 0 or not. Pi K plus 4 pi K 3 by 2 minus 1. We can get pi K plus 3 by 2 minus 1, 1 by 2. 1 by 2 means we will get 2 pi K. The value is 3 pi K on net charge on the sphere. If charge is in 3 pi K is there, then we can write the electric field is on the outer shell is not equal to 0. So first option is a wrong option. Now RB is equal to 3 by 2. Now let us consider that we have like Q value Just now I have written the q value is pi k 4 pi k rb square minus 1, pi k plus 4 pi k rb square minus 1. Now we are calculating at a distance of, if rb is equal to 3 by 2, what will happen, we'll see now. The net charge q is equal to pi k plus 4 pi k 9 by 4 minus 1. We can get pi k plus 4 pi k 5 by 4. This one get cancelled. We can get 6 pi k is the net charge. Now what is the potential at that point they are asking? What is the potential? Potential at any point is V is equal to K Q net divided, this is net charge, Q net divided by the RB you write. So K is K is nothing but 1 by 4 pi, 2 K's are there here, 1 by 4 pi epsilon naught. So I can add 1 by 4 pi epsilon naught into 6 pi K divided by the RB value is 3 by 2. If you write this value, you can get 12 by 12. That value pi also get cancelled, K by epsilon naught. So potential at this point is correct. If you observe this, at RB is equal to 3 by 2, this value is correct, K by epsilon naught. Now RB is 2, you have to calculate charge is how much. Now at RB, C option I am calculating, at R is equal to 2, RB is equal to 2. Charge Q can be written as pi k plus 4 pi k 2 square 4 minus 1. You can get the 4 pi k, pi k plus 12 pi k, 3 into 4. So you can get 13 pi k. According to question, it was given that 15 pi k. So 15 pi k is wrong. At RB is equal to 5 by 2, electric field is how much? RB is equal to 5 by 2. D option. At RB is equal to 5 by 2. Now Q value will calculate 5 pi k, 4 pi k, 25 by 4 minus 1. We can get pi k, 4 pi k. This is 21 divided by the 4. 21 divided by the 4. 4 get cancelled. You will get 22 pi k is a Q. Electric field at any point, E into 4 pi into RB square, Gauss law. I am applying Gauss law. So E bar dot A bar is equal to Q by epsilon naught. Q by epsilon naught is 22 pi k divided by epsilon naught. We can see E into 4 pi into RB square is 25 divided by the 4 is equal to 22 pi k divided by the epsilon naught. Pi and pi get cancelled, and we can get the value is E is equal to 88 k divided by 25 epsilon naught, and 4 also there. 4 get cancelled now, 1 minute wait. So you can see here 4 and 4 get cancelled. Now finally we can write the relation as E is equal to 22 k divided by 25 into epsilon naught. This is the D. So if you see that D option 13 pi k by epsilon naught, this is wrong. So according to options, if you see that first option, we are getting like a first option at A is E not equal to 0. Next option, if you see that B is k by epsilon naught we are getting. So only option is available is option B.